Okay, welcome to the session on IPv6 on Windows. I gather that most of you use Windows, is that correct? I know it's Jeremy's favourite operating system. In fact, he said to me just a moment ago, he said, David, don't want to do my presentation on my laptop. Please can I do it on yours because you're running Windows XP? I said, that's okay, Jeremy. Anyway, I'm David Holder. I work for a company called Erion. We've been working with IPv6 for over 10 years. We provide training and consultancy services. We've also been working for a lot longer than that with Unix and Windows integration and also with Samba, hence my involvement, shall we say, with Jeremy, which I'll talk about a little bit later on. What I want to do in this talk is just to give you a bit of high-up stuff and some detailed stuff as well that I think you'll find useful to know about Windows and IPv6. So I'm going to give you some background. Then we're going to dispel some myths that are out there which may confuse you or mislead you. And then I want to delve into some details that I hope you'll find useful. I could spend hours talking about details of how IPv6 works on Windows. I'm sure you'd love that, but I haven't got hours, unfortunately. And then finally, I'm going to make some comments about developing applications on Windows using IPv6. Okay. So, first of all, a little bit of history. Here we've got a little diagram to help you understand how Microsoft have developed IPv6. You see, way back in 1998, Microsoft Research produced this stack that you could try out. It had lots of useful applications in it. Let me think. Ping, Telnet, and that was about it. So it's quite limited, but what it did give you was the socket API that you could use, and you could actually try out using IPv6 as a bolt-on. And then with Windows 2000, there was also a technology preview that came on after that. These were stacks. They didn't change the operating system. You didn't have any additions to the GUI, or Active Directory was not IPv6 enabled. Neither was file sharing or printer sharing over IPv6. That came with the advent of Windows XP, where you got an IPv6 stack that came as standard with the operating system. It wasn't enabled, but it was there. With SP1, it moved from being a developer stack to what Microsoft referred to at that time as a production stack. I'm not sure what phrase to use here, but from things that were said before, you probably picked up that nobody would genuinely use this as a production stack. You didn't get full DNS transport, well, DNS transport over IPv6, as we mentioned previously. You didn't get integration with the operating system or with the GUI. So there are a lot of things which would stop you using it in a production environment. Even so, you could do. Because if you're a developer and you're writing a business application for your organization, you could write it for IPv6, and because it was a production-supported stack, you could use it over IPv6. Okay, and then we had this advanced networking pack appeared, and finally Service Pack 2, you got a lot more. So you got a firewall that was IPv6, not just IPv6 aware, but fully IPv6 functional, plus Teredo and peer-to-peer functionality. And at the same time, Windows 2003 gained the same kind of IPv6 functionality. Now, at this point, you had a lot of functionality. You had an IPv6 production stack, and you had a lot of tools that worked with it. But what you still didn't have was full integration with the operating system or availability of IPv6 addresses in the GUI. And so, whilst you had a lot, you didn't have Active Directory, which was a minor problem for many organizations. So there's a lot of things you could do, but I suspect 99% of companies wouldn't use this for IPv6. Now, the world changed with the release of Vista, and will change even more with the release of Windows Server 2008. Because unlike previous versions of Windows, these are IPv6 operating systems. And IPv6 is fully integrated into everything, as we'll see. Okay. I think this is very important for IPv6. I think Google needs to take note of this because of the impact that I believe it will have upon the take-up of IPv6 in the world. Let's just recap. IPv6 is enabled by default. It's the preferred protocol, which is what should happen in an IPv6 stack. You have IPv6 and you have IPv4, but you use IPv6 in preference to IP4. It's configured automatically. It's fully integrated. It works in IPv4 networks. You have ISOTAP, you have Teredo, and it's fully supported in Active Directory. So what I think is going to happen is this. People will install Vista knowing nothing about IPv6, and they will use IPv6 knowing nothing about IPv6. Small businesses will install Windows Server 2008 knowing nothing about IPv6, and guess what? They'll use IPv6 without knowing about IPv6. And at the other end of the scale, you'll have many large organizations that have been thinking about IPv6, but Active Directory has not been IPv6 enabled. So they'll have held off. Now they've no reason to hold off. So you'll have IPv6 increasing the usage of IPv6 by stealth and by design. My jokes about Microsoft operating systems have just unfortunately bit me as it's crashed. However, I think I know the reason. It's that open office software I installed for Jeremy. It stuffed me. Now, if I tell you this has never happened before, you just won't believe me. But it's true. OK. One thing to be aware of is what you read on the internet. You do a Google search, you get loads of things about Windows, and particularly Windows Vista and IPv6, and absolutely masses of it is false and untrue, full of facts about IPv6 that are wrong, like it's got 64 bits in the address, and more serious things. So, for example, you have stories of how IPv6 on Vista ate people's cats, reduced their network performance, introduced security issues. Now, at Orion, we've been using and testing this for a long time. And we have found that if we work hard and if we do things which are stupid, we can make IPv6 slow things down and reduce security. And we can do that with IPv4 too, and we can do it on Linux. So don't believe everything that you read. Watch out. When it comes to Windows, the Windows IPv6 stack is now on a par with Linux, with Solaris, with HPUX, with AIX. There are technical differences, but they're on a par in terms of functionality and usability and robustness. OK, just as a little comparison for you with a well-known open software product called Samba that does similar things to what Windows does. This to give you a clue as to how well Microsoft have done and how far behind open software is. Well, actually, it's catching up. But what we have here is a timeline the same as the previous one, which shows you where Samba is with IPv6. So Samba 2.2 is not recommended anyway. Samba 3 can only use IPv6 if you run it through a superdaemon. And for those who know about running Samba through superdaemon, you know it is a bad idea. Jeremy's shaking his head. You don't do it. So that's a bad idea. Now, last year here at Google, I said to Jeremy, you really ought to IPv6 enable Samba 3.2. And Jeremy said to me, I'll do that, and I'll do it in a couple of weeks. And I said, no, you won't. It will take ages. Credit to Jeremy, he did it. And I've been testing this, and this morning before breakfast, I did the world's first ever IPv6 join of Samba 3.2 to Windows Server 2008. And that's due to Jeremy and his colleagues. Now, Samba 4 can be IPv6 enabled with a hack. Early last year, the Linux CIFS client, myself and Steve French, got that to do the first connection over IPv6 to Windows Server 2008. So, by the time Windows Server 2008 comes out, all of the Samba family that matters will hopefully be IPv6 enabled. Okay, a few things you need to know. This has been mentioned many times, and I get the impression a lot of you will know what a dual stack is. Windows uses a dual stack. What this essentially means is that it's an IPv6 stack, because all IPv6 stacks are dual stack. And that means that when you write an application, and it's an IPv6 application, for free you get IPv4. It also means if you have an IPv4 application, it can still work on the IPv6 machine, which is pretty cool when you think about it. But it does have many implications for your administration of Windows and other platforms, and also for how you write applications for IPv6. Okay, let's just look a little bit detail of things that might catch you out. Earlier on, there were a few mentions of IPv6 addresses. Now, with Windows Vista and Windows Server 2008, Microsoft have made a choice that the default way that the last 64 bits, what's called the interface ID, will be created is by using a pseudo-random number. Now, most other platforms default to using EUI64, which is essentially your MAC address expanded to 64 bits. Now, Microsoft on Vista give you two addresses. Now, two global addresses, that is. You actually have many IPv6 addresses. And if you look at the interface identifier for these two addresses that both have the same prefix, you'll notice that they're different. And this was mentioned earlier. This one is your permanent address that the outside world can connect to you from, assuming you haven't got a firewall, which of course is on by default, remember. So it's secure. This one is your throwaway address. And the idea is that you have this address that you use when you're a client connecting to somebody else. Now, I actually personally think this is a, just trying to think of the word, bad idea, for all of the reasons that have been mentioned earlier, because it's a management pain in the neck. It might give you some security in obscurity, but to be quite honest, when you're trying to set up filters on your firewalls, when you're setting up any kind of security that you want to link into your IPv6 address, it's a nightmare. So, hey, I don't think it's a great idea. But watch out for it. So you'll have multiple addresses and the interfaces are randomly generated. Let's have a look at how they're written in Windows, how you actually textually represent these addresses, because this is crucial for administrators and for developers. You have a global address or a LinkLocal address, and the format is like this. You're familiar with this, the hexadecimal with the colons in it. Here we have a %, and that indicates that the number or the name after it is the interface that address applies on. One thing to watch out for is if you're using LinkLocal addresses, you must specify the interface on a multi-interface device, because there's no other way of knowing which link it's related to. Here's an amusing thing that you might notice from this picture. This is from Windows Vista, but it could have been from Windows Server 2008. You'll notice that it's been carefully designed so that it crops the end off the IPv6 address and you can't see the last few digits. Please, if you're a developer, make the fields big enough. Okay, here's another form of the address that you can have. This is your IPv4 mapped IPv6 address. It's an IPv6 address. If you use this address, I'm sorry for those at the back who can't see it, it's got a prefix 96 bits long, beginning with : FFFF. And the last is dotted decimal. It's an IPv4 address bunged inside an IPv6 address. The stack, a dual stack, uses this address to tell it that it must use the IPv4 protocol. This is the way that you can write code that uses IPv6 addresses everywhere, even when you're doing IPv4, which is cool. In addition to this, there's a new notation for URLs URIs and UNCs. Let's have a look at URIs and URLs first. Because you have letters in an IPv6 address, it looks like it could be a domain name. So you can't write http:// and the IP address as you could with IP4. With IP6, you have to indicate it's IP6, so you put square brackets around it. However, this doesn't work with UNCs because in Windows, with UNCs, the square bracket has got a special meaning. So you can't use square brackets. So Microsoft have invented something that isn't used anywhere else, which is a domain which has got the IPv6 address written into it. And the resolver changes this. Don't worry, I'll show you another slide with this for those who can't see it. Here it is. So what you do is you replace the colons with hyphens. I'm sure this is intuitive. And if you're using a LinkLocal address, which this is, you replace the interface identifier, which is normally a %, followed by the identifier, with an S. Yeah, S stands for interface. Okay, I need to move on. File sharing in IPv6. You can only do it over raw SMB with port 445. Name resolution, absolutely crucial. The old stuff is IPv4 specific, doesn't work. On Windows, your host file works, your DNS works fully now, thankfully, and there's a new protocol called the LinkLocal multicast name resolution. Does anybody here use multicast DNS? This is not the same protocol, but it looks very, very, very similar. And it performs name resolution without DNS using DNS-style packets, but it does it over multicast. And this is great for small networks. You plug your machine on and you can see all the other machines using multicast. So that's pretty cool. But it's not multicast DNS. Transition mechanisms. This could take several hours or a few days on its own. The key ones for Windows are shown here. So you've got 6-4, ISOTAP, Teredo, and the most important of all, which is dual stack. And we've already heard many bad things about transition mechanisms. Really, in an ideal world, we would avoid a lot of them like the plague. The best one out of these is the dual stack. But of course, life isn't as simple as that. Okay, right, developers. On Windows, you'll find that Visual Studio, C and C++ and so on all support the latest incarnation of the IPv6 socket API. It's gone through many incarnations, so make sure you use the latest one when you're developing your applications. Make sure you use it so that it's protocol independent. You can now write code that doesn't have to specify whether it's IPv6 or IPv4. The code is generic, and that is a fantastic feature of IPv6 and the new API. Okay, so, and don't forget, you get IPv4 for free. So I've just got a few references here for you to read when you get time. So just to summarize, with Windows Vista and Windows Server 2008, you get two operating systems that are completely IPv6 enabled by default. And everything works as it should do, pretty much. The new things that you need to be aware of when you first start using them are things like the address configuration, the way that Microsoft does it, the formats of the addresses, the address resolution, and also the transition mechanisms that it uses. And for developers, programming in IPv6 on Windows is just as easy it is, if not more so, than on Linux or other platforms. Okay. Thank you very much. Any questions? Well, I'm out of time. Is it okay to answer? Yeah? Okay.
You mentioned that with Windows it's easy to develop for IPv6 and the stacks all supported. Has this been backported and put into automatic patch for older versions of Windows, or are developers tying themselves into Vista only when they do this?
Well, yes, it has been backported. By older versions of Windows, I only mean Windows Server 2003 and Windows XP. You can forget earlier versions. But whether you're going to use those platforms for IPv6 is kind of debatable.
Yeah, I was wondering what you know about the performance of Teredo tunnels and whatnot. I mean, how bad is it if somebody tries to set up a Teredo tunnel to some site?
You mean in terms of performance, not security?
Yeah.
Right, okay. Well, the performance, you've got to remember that with Teredo, what you're doing is you're encapsulating your IPv6 inside UDP. Mm-hmm. So you have the overhead of UDP plus the overhead of IPv4 plus the additional processing. So there is a performance impact, which is worse than just an IP in IP tunnel.
When is the tunnel set up, though? Is it on the first request, or is it set up already? So, I mean, how bad is it? Does it stay up?
Oh, I
after
see
that?
what you mean.
You know,
yeah.
like if we turn on a quad A for people and they all of a sudden they start generating Teredo tunnels, I mean,
no.
How bad is it going to be?
Okay, this is an important issue, not just because of the performance, which is actually less of an issue, but also because of the security question with Teredo. It can be used to create backdoors into people's networks, because it's a very, very aggressive protocol for getting through multi-layers of NAT successfully. And it does it very, very well, so it creates a lovely tunnel through all of your security. What you need to be aware of, though, is that in enterprise networks where you're using Active Directory, it is switched off. Right? So that you can switch it on, but the default security policy is that it is off. For home networks, which is where it's intended to be used, it's switched on. But of course, it only works if you've got a Teredo server that it can connect to.
I guess we'll find out then.
Yeah.
Thank you.
Okay, thank you.